Hey everybody, we are looking at this problem product of array except self. Given an integer nums, return an array answer such that answer I is equal to product of all the elements of nums except nums I. For example, if nums is equals to this, then we are supposed to return an answer where every element is a product of every other element except the element at that particular index. If this is I, and over here this is also I. So 24 is the product of all these elements 4, 3 and 2 except 1. Similarly, if we go to this, let's say this is I, this would be I, then the value at this position is equals to the product of every value other than this I, which is 1, 3 and 4. So that is 12. Very similarly for this and very similarly for this. We are also given that the product of any prefix or suffix of nums is guaranteed and it fits under 32 bits. So basically, we don't have to worry about going out of bound. We are supposed to write an algorithm that is O of n, and we cannot use a division operation. A simple solution that would come to anyone's mind is how about we calculate the multiplication of every element and then divide it by the element at that position I. So the multiplication of this is 24. So for every index, you divide it by the element at that index. So 24 by 1, 24. Now 24 by 2, 12, 24 by 3, 8, and 24 by 4, that is 6. But of course, we cannot use the division operation. So this would be invalid. Also, there is a problem with this algorithm. What if we had 0 over here? In that case, the multiplication would be 0. Every other element, should be 0. This should be 0. This should be 0. But over here, we have to divide 0 by 0. And that would be invalid and that would not give us the right answer. So this we cannot answer and this would be 0. So of course, this algorithm cannot work that easily. So to solve this problem, we are going to make an observation. Let's say I is over here. What is the value at this position? It is basically the prefix multiplication and the suffix multiplication. We don't have to worry about the value of it. So if we can find out the prefix and the suffix, we would be able to find the value at this position as prefix multiplied by suffix. Now, how do we do that in O of n time? Now let's calculate the prefix. Let's say we are at this particular element. The prefix right now is nothing, so we are going to assign this prefix to the identity element of multiplication, that is 1. Let's take an array of size 4. The prefix for 1 would be basically nothing, so that would be an identity element of 1. When we move I forward, I moves here, this connection is broken, this I moves forward. This 1 would also become part of the prefix. So we would update the prefix, which would be 1 multiply 1. So we would call it 1. From 2, we can see that the prefix is 1 again. And we can also visually see that it is 1. Now I moves forward again. I moves to 3, which means prefix is now multiplied by 2, the element that we left. So the prefix is multiplied by 2. From 3, the prefix value is 2. Let's move I forward, and every time we move forward, we multiply the element, the element that was I before, we multiply that with the prefix. So this 2 becomes 6, which means for 4, the prefix is 6. We can also visually see that. Now, can we calculate suffix very similarly? Let's take this array again. I have suffix equals to the identity element 1. Let's say this is called a j. The j is pointing to 4. The elements on the right There are no elements, so basically the suffix would be 1. Let's move j forward, which means multiply suffix with 4. So this becomes 4. For 3, the suffix is 4, so I would write it here. Let's move j forward and multiply 3 with the suffix. We have 12. So basically we can say for 2, the suffix is going to be 12. J moves forward again. This 2 is multiplied by suffix. We have 24. So this would be 24 here. Now we have, for every element, we have its prefix stored here and its suffix stored here. So if we multiply these two arrays, what do we get? We get 24, we get 12, we get 8, and we get 6. And this is our solution. In the follow-up section, we are also being given that do not use extra space. They are not counting the space used to store the results as extra space, which means we can only have one extra array which we are going to return. Here we have two, prefix, and we have this suffix. We are not allowed to use these two. How about we just use one? Anyways, we are just storing these values. So if instead of using an extra array, if I just simply multiply the value of suffix in the prefix array, that would mean exactly the same. So we are not going to use two arrays, but just one, both to store prefix and suffix. So now this would be the basic algorithm. Let's look at the code implementation and understand it better. We are here in the code editor. We have this function given and a nums array, and we are supposed to return a list. That would be the result. Let's create a list result. I would assign it with 1, the identity element for multiplication. Multiply by the length of nums. I want this to be a size of length of nums. Next, let's calculate the prefix and the suffix. So prefix, I would assign it to 1. For I in range length of nums, I would like to store the value of uh, prefix at that index. So result I would be basically the value of prefix at this index, and that can be result I multiply by prefix. Even if I don't do result I over here, that's fine because all the values are 1, but I'm still doing it. So we are just storing the value of prefix right now. Once we are done storing the value of prefix, let's increment the value of prefix. So prefix would become the number at this position multiply by nums. So when we are at I plus 1, the prefix we take also includes the number I. Sorry, it would be prefix, not num. So nums I multiply by prefix. This should be done. This should be good for prefix. Let's go for suffix. Suffix equals to 1. For j in range length of nums minus 1 until 0 we will go, and taking a step of minus 1. This is, we are going from right to left in an array. Now let's store the suffix value. So result I equals to, very similarly, sorry, not I, it should be j. Result j multiply by suffix. This would not just store the value of suffix but also multiply that with the prefix we already have. So this should be the final answer. Now let's increment the value of suffix. Suffix equals to nums at j multiply by the suffix we already have. Now this should be it. Let's just return the result from here. Let's run this code. Let's submit it. So we have a solution. If this video was helpful to you, please consider subscribing for more such content.